We will now discuss how a refraction of a plane wave occurs in a medium using Huygens principle. So, let us first consider a plane wave that is falling obliquely to the medium, and we assume that here we draw a perpendicular, so that we assume there is a there are particles that are oscillating in phase. So what we are assuming is, in the first medium, v1 tau is the distance traveled by the plane wave, and at the same time, due to refraction, v2 tau is the distance traveled in the second medium. Let us assume the velocity may vary. Here we draw according to the diagram. It may vary, it can be positive or negative, which means the velocity can increase or decrease, but we consider here it is less than the v2 is less than v1. So in this case we can say that bc is equal to v1 tau and ae is equal to v2 tau. Just consider the triangles abc and AAC, so that we can write sin I is equal to bc by AC, and bc here is a v1 tau, so we can substitute v1 tau by AC in the first equation, and we can write sin R is equal to v2 tau by AC in the second equation. So what we are assuming is, angle of incidence I is the angle in this triangle ABC. Angle BAC is angle I because of this triangular arrangement. So we can say that this is a right angle triangle. That is why we got this relation. At the same time, we assume that v2 tau, it may be any kind of thing, but we assume that it is a wave front, so that we can draw a arc, or we can, if you draw a circle around the point A, we may note that this is the wave front from the plane wave. So we can just say that this AE represent the plane wavefront part we need, so that we can say that v2 tau is the distance traveled in this time. So we can say that this is the refracted wavefront form. Okay. When we divide equation number 1 by equation number 2, we get sin I by sin R is equal to v1 tau by AC into v2 tau by AC, so that we get v1 tau by v2 tau, because AC is common. v1 tau by v2 tau means tau cancels, and then we get v1 by v2. Sin I by sin R is equal to v1 by v2. So from this relation we get, when R is less than I, the denominator is less than I, so that the right hand side also follow the same rule. v2 is less than v1. So it says that if in the second medium, if the light bends towards normal, that is what R is less than I, then the velocity must be less than v1. In the first velocity of second velocity in the second medium is less than velocity in the first medium. v2 is less than v1. So if the light travels from rarer to denser, velocity decreases. This is the actual experiment shows this relation, so that we can verify the wave theory suggestions are correct, and we can say that corpuscular theory suggestions are wrong. So we confirm that wave theory is useful in such a such an assumption. It may be right. Okay, then we can write n1 is equal to c by v1. Similarly, n2 is equal to c by v2. This is the relation for refractive index of medium. So n1 is refractive index of medium 1, n2 is refractive index of medium 2, so that we can write n1 is equal to c by v1, and n2 is equal to c by v2. When we write n2 by n1, we get C by V1 by C by V2, that is V2 by V1. We want V1 by V2, so that we can write N2 by N1. Okay, so we can write N1 sin I is equal to N2 sin R. This is the relation that is already derived in refraction, that is known as Snell's law. So we can prove Snell's law using the wave aspect, wave rule. So if we assume the same rule, we can say that we know that BC is the distance traveled by the plane wave by the time tau. So we can say that BC is the distance traveled, and if we assume that as a wavelength, which means a single wave is transmitted between this distance, then because of this plane wavefront or a wavefront phenomenon, we know that AE should also travel the same distance. So lambda 2 is the distance traveled in this case. So we get a V1 by V2, or V1 by lambda 1 is equal to V2 by lambda 2. This says that lambda 1 by lambda 2 is BC by AE, that is equal to V1 tau by V2 tau. Tau cancel, and we get V1 by V2. So if we rearrange the equation, we get V1 by lambda 1 is equal to V2 by lambda 2. It says when V2 decreases, lambda 2 also decreases. So as it passes from one medium to another, velocity and wavelength may decrease, but frequency remains the same.